Today we'll see how to work with typecasting. Some technical points are there on this topic. We'll see those technical points. Then we will see other conversion techniques. First point, for example, if I say byte A equals to 127, again, byte B equals to 128. A is 127, B is 128. C equals to A plus B. Then I print console.writeLine sum is plus C to get the result. Now, first thing, value in A is in range of byte data type because its range is up to 255 and I gave 127. So that's fine. B equals to 128. That is also fine. That range of B is also, value in B is also in range of byte data type. When I add them, A plus B, when I say, so the result is 8 plus 7, 15, 5, 1, 4, 5, 255. So C value is also in range. So this is most frequently asked queries. This actually will make you learn importance of typecasting. Simple program is only about addition of numbers. But if I don't say, if I don't go with this point, usually we do this mistake. You feel all techniques will be same in calculation, and in interview if they ask the question asking you to return the result, definitely people do mistake of writing sum is 255. There will come to a point of how good you are in understanding the conversion techniques in C sharp. There ends your interview chances. So for that point, what I conclude now is specially for three data types, specially for three data types: byte, short, character. For whenever with these three data types, whenever you make mathematical expression, whenever you make mathematical expression, by default, it raises it raises that expression to a rank of int data type. It means this expression now it considers as integer expression. Copy this code, come back, put here a plus b is error. Yes, error. Put your cursor here. Error. Cannot implicitly convert type int to byte. An explicit conversion exists. Did I talk anywhere about integer data type? No. Then what is from where this point has come? Cannot implicitly convert type into byte. It means this expression is now being considered as of integer expression. It is being considered of what? Integer expression. For that reason, you can find that a plus b has become of what? A plus b has become of what? Integer expression. So we want to consider it as byte. Simple. This a plus b you have to keep in parenthesis, and before a plus b you have to put byte. But run the code and you can see sum is result. Yes, 255. Sum is 255. Acha, another important story. Same case we'll try for short. Short I equals to 16,000. Short j equals to 16,000. Short k equals I plus j. Then console.writeLine sum is plus k. Then same issue here also. I plus j is error. Error. So then this you have to put in brackets, and then this should also be converted to short. Yes. Now run the query. You get your result. 32,000. Same story is Fasha. Sometimes expression is given in this way. Byte x equals to 200, short y equals to 32,000, short z is equal to short x plus y, console.writeLine sum is plus z. Execute. Same. If I don't write short, same problem. Byte and short. Not necessary that expression is only of about byte. No. Whether it is byte or it is short or it is combination of byte, short, char, in any of the three cases, always expression is raised to a rank of what? Integer type. Okay. I'll show you another scenario also. This is also a technical query. Now, for example, I'll go to Notepad again. Now, first they compare. They'll drag answer from you like this. Scenario 1, scenario 2. First you say like this. Integer I equals 18. I plus plus. Console.writeLine I. Then immediately another scenario they'll ask. Integer I equals 18. I equals I plus 1. Console.writeLine I. Scenario 3. Byte x equals to 18, x plus plus. Console.writeLine of x. Scenario 4. Byte x equals to 18, x equal to x plus 1, console.writeLine of x. Now here for integer now output 90. Here output 90. Perfect. Down. Here output 19. Here error. You won't get output. You don't get output. It will be error. Compile time error. Why? Because x equal to x plus 1, when you say that x plus 1 will give you error. X plus 1. It will give you error. Why it will give you error? As I already said you the reason. Because whenever you write mathematical expression with byte data type, that will raise to a rank of what? Integer type. For that reason, you'll get compile time error. it doesn't work for you. Error, compile time error. Compile time error. Same. Cannot implicitly convert type int to byte. That message is there is scenarios. But for integer, you see, for integer, valid in both the cases. Both cases. Both cases it is valid for integer. I plus plus or I equal to I plus 1 means same. Scenario 3, 4, you see, x plus plus, x equal to x plus 1 makes a lot of difference. X plus plus works, but x equal to x plus 1 will not work. No, it doesn't work for us. Okay, lot of difference on those two statements. Okay, exactly same way. Coming to another point in typecasting, and that point is, say, here I write, Boolean I equals true, Boolean variable. Integer j equals I, j equal to I. Already it is giving error. It is giving error. Yes. The message what you got it cannot implicitly convert type Boolean to integer. Cannot. You cannot convert implicitly what? Boolean to integer. Not possible. Then what to do? Then what we have to do to convert that? What is the process? How to do this process as we are trying directly? So usually as implicitly not allowed, we get a thought of going for explicit. Explicit is also error. Error will not be removed, rather error will be increased, which comes to a conclusion now saying that Boolean, uh, yeah, Boolean to integer, Boolean to integer, implicit, explicit, both are errors only. Boolean to integer, implicit, explicit, both are errors. Both are errors, I'm saying. If I do reverse, like this, integer I equals 1, Boolean j equals to I, here you are converting integer to Boolean. Previously it was Boolean to integer. Now we are trying for int to Boolean. Int to Boolean is also compile time error only. Same. Now in brackets, if you convert, writing Boolean is also an issue only. It doesn't work. So now I come to a conclusion. Now, and the conclusion is, remember, instead of saying only integer to Boolean, it would be best if you say any type to Boolean and Boolean to any type. Any type to Boolean and Boolean to any type. Implicit and explicit. Both typecasting concepts are compile time errors. So conclusion is typecasting does not support to convert any type to Boolean and Boolean to any type. Not possible. That's simple. We don't have typecasting, doesn't support at all. Instead of targeting only integers, better I say any type. Same concept, I write again. Same concept. Now what I say? Integer I equals 18, string j equal to I is also error. Yes. Here, cannot convert int to string implicitly. But doesn't mean like there is explicit casting here. Don't write string. This will end up with error now. Yes. So now this is another limitation of typecasting. Integer to string or string to integer. Better I say any type to string, string to any type, implicit, explicit typecasting not allowed. Any type to string and string to any type, implicit, explicit casting is not allowed. That is also an issue. That is one more limitation of typecasting. Another important scenario. We don't know about it, and we will discuss about this only in OOPS. And that what we have is something related with the what do you call generic type. Generic type to value, generic type to value type, or value type to generic type. In any of the cases, remember we don't have typecasting support, so we don't know about generic data, generics at all. That OOPS concept when we go now, at that time I'll explain you the importance of it. But at this point of time, just remember this point as theory. The generic to any type is not valid. Implicit, explicit, both are not allowed. So there are now, I confirm, three limitations. One limitation is any type to Boolean, Boolean to any type, not possible. Second, any type to string and string to any type, not possible. And generic to any type, that is also not possible. The two implicit express, both are not possible. That is another point. These are the three cases that you have now. Now, to overcome all these
Explain
problems,
generic.
huh?
Sorry, sir. Could you please explain generic data types? What is the generic data types?
Generics is one topic we have in OOPS. Generics.
Okay.
In the topic will come across. At this stage, not required. Just remember that as a theory.
Okay, sir.
Generic type to
Okay, sir. Fine.
specific type, implicit, explicit casting, not allowed. I'm talking only about limitation. The
Not
third limitation I said, OOPS, when we start, there is a concept called generics in it. Then I'll correlate this point. Then you'll get to know perfectly. Now,
okay, sir. Fine.
whatever the things which are not possible with typecasting, those you can do with the support of conversion method. Conversion method. That conversion method we can implement by using convert class. By using what? Convert class. Now, how to use this convert class? What is the process of using this convert class? So I say, for example, first normal scenario I'll show you. Integer here. Integer I equals 19. I want to convert to byte. J equals I, not possible. Console.I write line I and J, not possible. So to make this work, before I you should write byte. That is typecasting, but not. I'm not interested in typecasting. I want to do same process, but using convert class. How? You should write convert class dot to byte of I over. Instead of typecasting, now I use convert class. Execute I and J will be 1919. 1919. But this time I'm not using typecasting. I'm using conversion method. Topic is same, conversions only, but approach we changed. Approach. Now this is int to byte using convert class method. Int to byte using convert class method. What about reverse? Byte x equals to 28, byte y equals to convert dot to into 32 of x. Convert dot 2 into 32 of what? X. Sorry, this is integer. Int y. console.writeLine x concatenate y. Control F. Yes, 1919 2020. Acha, especially in this case, instead of x 19, I'll keep 219. No issue, valid. Okay. Instead of 219, I'll keep 255. Then also valid. Now keep 256. In typecasting, it will go with not type say, and value will be returned as 0. But in conversion method, if value exceeds to byte data type, this will end up with error. It means conversion method by default makes your conversion type safe. Error it is. Overflow exception. Overflow. Though I don't write checked block. Though I don't write checked block, still you could notice that we are being provided by what? Same error. That is int to byte to int. We are done with what? Implicit and using conversion methods. We'll try one on it. Now what I do is I say integer I equals to 1, boolean j equals to convert dot to boolean of I. Console.writeLine I concatenate j. So in this case, what you're doing, we are converting integer type to boolean. Typecasting was not allowed, implicit was not allowed, explicit was not allowed. So I'm using conversion method. Now I'm converting integer to boolean. If I run my code, obviously it will return your answer now. Now you find I1 j true. True. I value will be 1 and j value will be true. 1 is a representation for true, for boolean. Acha. Another scenario. If I give I as 0, 0 means false. False. Another scenario. 1 means true, I said. But actually, 0 means false, okay. But 1 means true, that is wrong. No. I can give any number, 1,90,999, true. If I give minus 19, then also true. Any positive, any negative number is always true. Any positive number or any negative number is always what? True. Except 0. 0 means false. Any positive, any negative is true. 0 means false. So which typecasting cannot do, convert method will do. Acha. String also I'll show you. String. Integer I equals to 19. String j equals to convert dot to string of I. Console.writeLine. I concatenate j. So what exactly we have done now in this scenario? We converted integer to string. So output now will be I is 19, j will also be 19, but that 19 will be in the form of string. Control F5. 19, 19. One is integer 19, one is 19 in the form of string. Now reverse you do, reverse string s equals to 189 integer t equals to convert dot 2 into 32 of S. S concatenates T. Last 189, 189. (1919, 189). Acha, another interesting thing. Especially when you're converting string type data, means number in the form of string, it is actually number in the form of string, and you're converting to integer type. You're converting to integer type. 189, fine, but don't put alphabets in it. No, this is not allowed. String can have only numbers if you're converting to integer type. You gave no alphabets, this will end up with error. Error. Format exception. No. Even don't try decimal also. 0.22. This is also runtime error. Same format exception. Because you treat as just decimal, but C# treats a special character and it won't allow you to convert. Achha, what about reverse? Reverse? Yeah, now you try. String S1 is equals to 189.22. Float P equal to convert dot to single of S1. Double Q equals to convert dot do double of S1. Console dot right line S1 concatenates P concatenates Q. Control F. Last three are valid now. Last three. Yes. 189.22, 189.22, 189.22. For float and double, you can give decimal point in string and then that can be converted. But if you are using integer, don't give string with real value. That cannot be converted to integer. So now answer. Any type to string and boolean and any type to boolean comma any type to boolean comma string and vice versa is possible with the conversion method, but not with the typecasting. Float conversion, there is no method called toFloat. Remember that point as well. Rather, you got a method called toSingle we have. Float P convert dot toSingle. And for double, convert dot toDouble. Double we have same, but for float, we don't find a method called toFloat. Rather, you find a method called what? toSingle. Using the toSingle method, we can convert. That is about what you call conversion method. Now, then we have little further on this topic that is called parsing. 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 And what you learn about parsing is, see, for example, here I say, uh, parsing purely, its job is to convert. What to convert, What do you say? Parsing. I'll show you one example, then I'll explain. String s equals to 123. Integer I equals to int dot parse of s. Yeah, parsing is string to any type. String to any type. That is parsing. I say byte j equal to s. Sorry, byte dot parse of s. Short k equal to short dot parse of s. Then long m equal to long dot parse of s. Then float f equals to float dot parse of s double console dot write line s concatenate I concatenate j concatenate k concatenate m concatenate f concatenate t. Yes, execute all or string to, you can see, respective type. All. String to int, string to byte, string to short, long, string to float, string to. But only that is only possible with parse. Parse is not meant for any other thing. Acha, try another scenario. S1 equal to 235.22, real number. Then I can say something called float p equals to float dot parse of S1 double q equals to double dot parse of S1 console dot write line S1 concatenate concatenate q concatenate q control F5. S will return real number, P will return real number, Q will return real number. Okay, that is how your parsing is used. And reverse, you have another part also. In reverse, another part, and that point is, if you are working with what do you call this is string to any type, no? That is parsing, and we have any type to string, that is using a method called toString. Using a method called what? toString method. So I'll show you a demonstration of that part as well. Okay, so that you'll get idea of both the cases. Okay, reverse examples I'll make now. Reverse. Now what I do for reverse example, I just select all this comment. These are examples of parsing, and I'll go with second part where I'll go with something called any type to string using a method called toString. How? Integer I 19 string s equal to I dot toString. Then float j equal to 12.22 f. Then string s2, this is s1, equal to j dot toString. Then I say boolean k equal to true. Then string s3 equal to k dot toString console dot write line I concatenate s1, j concatenate s2, k concatenate s3. Yes, run the code. You'll get respective values. All what you did, you converted from any type to string. Using which method it is? ToString method. And that is using what now? That technique is what now? Okay. Simple. This is a topic for parsing. Boolean also you see last minute. Boolean k equal to true. String s3. Last statement you see. Your true, true. Both are true because your given value is true. String s3 is also containing true. Both are true and true. Now next part, quite very much important. It is something called boxing and unboxing. Boxing and unboxing. Now, what actually will happen in boxing? The answer is, listen, integer I equals 43, I variable containing value called 43, object, we have a data type, object, which is reference type action. Then I say j equal to I, object j equal to I. When I say object j equal to I, what is happening internally? Remember, this is what you call boxing. If I display na I and j, no doubt it will go with 43, 43. Yes, but something important is what is happening in these two lines of code that we should know. For that, I'll come up with architecture. I'll put that code here. Yes, I placed that code. Yes, 3 lines of code. Is it not looks like object j equal to I? Looks like you're copying I value to j. Looks like that you're copying what then? I value to j. Copying I value to j. It looks like, but what is internal happening? Now we will draw one architecture for this. This is heap memory. Heap. This is stack memory. Two things. Stack, heap. I, j. I. And second is what? J. I'll show like this. I and J. Same copy I'll make, but J also. First J will be there because stack na D4. So first J and then you'll have I. I. I contains 43. I contains 43. Now internal what will happen for boxing? This 43 from stack, it will move to heap. So heap contains 43. It moves first. Then what happens? It will create a box for that value. That's what the topic is, boxing. So it will box. Then for that box, it will give a reference pointer. Some address, big number will be there. Because we don't know how to check addresses at this stage. So I'm assuming it as pointer. And that pointer, it will return to J. That is what happens internal. So this pointer J. Now I'll give numbers so that you can remember that is what is happening in your boxing. 1, 2, 3, 4. Okay. All steps I'll cover here. 1. Step 1. Step 2. Step 3. 3. Step 4. Now explain every step here. 1. Copies value from stack to heap. That is step 1. Then second step, what we have done is, second step में create box for that value in heap. Third step, create reference for that value in heap. 4. You can say returns reference from of that value to stack. That is what is happening in your boxing. What is unboxing? What is happening in unboxing? In unboxing, we try again. Direct, I'll say integer k is equal to j. Integer k equal to j. Int k equal to j. K is integer variable, j is object type. Here on the left side you can see object j equal to I. And now you're doing reverse. And first thing, this is compile time error. This is compile time error. It doesn't work. Why? Implicit casting is not allowed. Then what to do here? Here you should write integer k equals to typecast j. Yes, this is unboxing, and that too with explicit casting. Unboxing, and it is through what? Explicit casting. Now you try to print both console dot write line k. Yes. (43). Answer is 43. Okay, why it is 43? Because console dot write line returns your k value as what? 43, because j was referring to 43, which is of integer variable. It's same thing if I implement. Same thing if I implement, because 43 can be there in byte also now. Byte can also store 43 now. So if we say byte p is equal to same typecast j, remember this is runtime error with a message invalid cast exception. Because why is it giving invalid cast exception? Because already it has been explained in boxing that j is containing a reference of a value which is of integer type, and you are asking to access it with byte, which is not possible. Straight away runtime error, you cannot access. Now, if you specially look into boxing, it's one line of code, object j equal to I over. Not only integer, actually I can give an example for any type. We can give example of what now? Any type. Problem is not with that. Problem is that internal, it is going with lengthy process now. Internal. Now what is that lengthy process? You can very clearly see the effect here. Very clearly. What is the effect? What is the effect you can see? One effect is that it is copying the value to heap, then creating a box, then it is creating reference for that box, then the value is being returned to stack. Code is simple and it can go for boxing, unboxing for any type, but problem is that lengthy process is going on. That is the reason it is very clearly mentioned that whenever we use boxing, unboxing, and if you use too much of boxing, unboxing in the application, that will degrade performance of the application. Degrades what? Performance of the application. And another scenario, especially for this boxing, unboxing, this also makes a rule. We cannot use boxing variables in your mathematical expression. I'll show you. integer A equals 189, B equals 100, object X equal to A, boxing, object Y equals to B, Z equal to A plus, sorry, X plus Y. Error it is. Straight away error. You cannot. It's error. I'll comment. Compile time error. Acha, try like this. Integer K equal X plus Y. Compile time error. Both scenarios it is same issue. Then how do you write this as a valid expression? Valid expression is like this. Int K equals to typecast X plus typecast Y. Now valid. Console. Yes. What did you do in this line? What did you do in this line? Obviously, simple. Unboxing. Unboxing to X, unboxing to Y. Answer is stored in K. That's it. This is the topic for boxing and unboxing. Conversion methods, parsing, and then boxing, unboxing. All three are covered.